Hello students, welcome all of you at AriserTalent. How are you all? I hope you are doing absolutely well. So, we are on the second chapter of the chemistry class 10, that is acids, base and salt. And until now we have discussed about the theories of the acids. That was a topic of discussion in our last session, that is what are the theories related to acid base concept. So basically we have deal with Arrhenius concept and the Bronsted-Lowry concept. Now we are proceeding to our third concept, that is Lewis theory of the acids and bases. So in the theory of acids and bases, we have the three theories. First one is Arrhenius. Second one is Bronsted-Lowry, and the third one is Lewis concept. So we have discussed the above two theories. The Arrhenius theory basically states that the substances which have a tendency to lose H plus ions in their aqueous solution are termed as acids. On the other hand, the substances or the compounds which have the tendency to eliminate or to dissociate to give OH minus ions are basically regarded as a basis. So this is in accordance with the Arrhenius theory that we have already discussed. Now Bronsted-Lowry used the concept instead of hydrogen. They considered the proton as the fundamental element, and what they said about it is the substance which are proton donors are regarded as acids, and the substance which are proton acceptors are considered in the category of the bases. So in the Bronsted-Lowry concept, we have gone through a one term also, that is the conjugate acid base pair, that I am discussing again here. So in the Bronsted-Lowry concept, we are discussing our next term, that is conjugate acids and bases. So our second topic is Bronsted-Lowry concept. So in the Bronsted-Lowry concept, we are dealing with the term that is called conjugate acid base pair. So what does this term basically indicate? Suppose I am reacting any acid. Suppose I am considering an HNO3. HNO3 is basically the nitric acid, and I am reacting HNO3 with H2O. What I am getting in the product side, I will get H3O positive plus NO3 minus 2. So in this reaction, we can see that this nitric acid will loses its one of the hydrogen, and this hydrogen is gained by the water molecule to basically form the hydronium ion. So I must say that this is acid because this have a tendency to lose hydrogen atom, and H3O have a tendency to gain that ion atom. So we can say that this is the acid base pair, and I can say that this is a conjugate acid base pair. So the definition of the conjugate acid base pair is that the reaction in which any acid base pair will have a tendency to mutual sharing or mutual gain or lose of the electron are known as conjugate acid base pair. So this is our acid 1 and this will be our base 1. So this will be regarded as a conjugate acid base pair. Now Here nitric acid will act as an acid, and on the other hand water will going to act as a base in this equation. Now we are taking the another example to clear our more concept regarding the conjugate acid base pair. Is this is our first example. Now we are taking another example for conjugate acid base pair. Suppose I am reacting NH3, that is ammonia, with water. So we are reacting NH3 plus H2O. Now here NH3 is ammonia, and ammonia will actually act as a base. So ammonia here is base and H2O will act as an acid, because ammonia is considered in the category of the base. Now after the reaction of NH3 plus H2O, what we are going to get in the product side, we will get NH4 positive plus OH minus ion. Now you can see here hydrogen will gain, NH3 will gain one hydrogen atom, and the corresponding atom will going to form the molecule, that is NH4 positive. It means bases have a tendency to extract the hydrogen atom from the corresponding acid by their side. So I can say that NH3 will take a one hydrogen atom from this and form the NH4 positive molecule with the liberation of OH minus ions. So we can see here that this is base and this have taken to form the acid. So now this can be considered as a acid base pair, and this is the another acid base pair. So we can say that this is base, this is acid, and this is again base. So this is our one conjugate acid base pair, and this is another conjugate acid base pair. So these are actually the conjugate acid base pairs. So this will be in accordance with the Bronsted-Lowry concept, who basically deals with the donation or the acceptance of the protons. Now we are moving to our third category, that is the Lewis concept of acids and bases. Lewis concept of acids and bases basically deals with the electrons. He doesn't give any idea of hydrogen, and he does not take the hydrogen as an active element for the reactions. So the Lewis concept basically deals with the electrons. In Arrhenius concept, we have dealt with H plus and OH minus ions. In Bronsted-Lowry concept, we basically deals with proton. Now our third category, we are going to deal with the electrons. But firstly, you can copy it from here. So, Arrhenius concept mainly deals with H plus OH minus ions. Bronsted-Lowry basically deal with protons. Now we are on our third category, that is Lewis concept of acids and base, and Lewis concepts basically deals with the electrons. So the major component here will be electrons. Is it all right? I hope these three concepts has been clear to you. Now our third topic will be the Lewis concepts of acids and bases. So we are moving to our third category, Lewis concepts of acids and bases. Now, what Lewis say about the category of the acids and bases, he does not involve the hydrogen atom to describe acid and bases. He just said that the components which are electron acceptors are regarded as acids, and the compounds which have the tendency to donate the electron pair are considered in the category of the bases. So, what is the Lewis concept of acids and bases? He said that acids are electron acceptors and bases are basically the electrons donor. So, acids are electron acceptors, and bases are basically electron donor. So we can say that in the equation or the reaction, if the someone is going to gain an electron pair is gained only when there is a lone pair of electron available on that atom. So electron pair acceptors are acids and electron pair donors are regarded as a bases. So this will be the two general conclusions according to the Lewis concept. Now we will take an example to understand the Lewis concept of acids and bases. So we have an example. Suppose I am provided with H plus ion. This H plus ion will basically act as an acid, and now I am reacting it with ammonia. Ammonia is NH3. NH3 will having a H and H here, having electrons. These are having the lone pair of electrons on the nitrogen. Now this is act as a Lewis acid. This will act as a Lewis base. Now what we will get in the product side is, the product formed will be, this H will combine with N, so this will be the actually compound formed by the reaction. H plus act as a Lewis acid and ammonia act as a Lewis base. These both will combine and have an entire positive charge on the compound because they are taking a electron from it. So we can say that this compound will act as a Lewis acid and the base. In general, we can write the equation . Generally, we can write the equation. Suppose we have an acid A and the base is B. Now, we are saying that acids are the electron acceptor and bases are the electron donors. So, the bases will having a lone pair of electron on it. So, this is our acid and this is our base. Now, the compound will be formed as follows, that base will going to donate its electron pair to the acid, and these two compounds will be bonded by a coordinate bond, and the coordinate bond is sometimes also known as a dative bond. So we can see that this compound will be bonded by a coordinate bond, and this coordinate bond is basically known as dative bond. This is another term for the coordinate bond. So you can easily see here that the bases having a lone pair of electrons is able to give its lone pair of electron to the acid. So acids are electron acceptors and bases are the electron donors. Now we will take in another example to understand the concept of Lewis acid and base. Suppose we are taking ammonia plus boron fluoride. Now we can see the reaction as a Lewis acid and the base as follows. We know that ammonia can be represented as NHH here. It will have a this electrons here. This is ammonia. Now I am doing its reaction with a BF3, that is boron. Boron will have a 3 fluoride ions. Now what will happen here? I am again representing the number of electrons here. This is BF3 molecule. This is ammonia molecule and this is BF3 molecule. Now the ammonia molecule will act as a Lewis base and this will act as a Lewis acid. So this is basically Lewis base and this will act as a Lewis acid. Now what we will get in the product side, we will get the compound and the compound will be NHH this will be the compound and this electron pair will shared here and the bond is formed, that is of the coordinate bond, and the bond that is formed between them will be the coordinate bond or dative bond. So I am representing the electrons here. So this will be the compound formed by the reaction of this and the compound will acquire basically a positive charge because this will be formed by the reaction of Lewis acid and Lewis base. So this is all about the Lewis acids and Lewis bases. Now we will discuss about the compounds which can act as a Lewis acid and the Lewis base. So our next topic is types of Lewis acids and Lewis bases. Now, which compound act as a Lewis acid and which compound will going to act as a Lewis base, we will discuss now. This compound or the substance which have its incomplete octet can act as a Lewis acid because it have a tendency to gain the electron pair. So, firstly, compounds with incomplete octet will act as a Lewis acid. Compounds elements which are electron deficient compounds are Na positive, K positive, calcium plus 2 positive. So these are the elements which are electron deficient. Thirdly, compounds which can expand their octet. The compounds which can expand their octet are SiCl4, these compounds that have a expanding octet, it means they have a tendency to acquire the electrons more than 8. So these are some of the compounds which will going to act as a Lewis acid. Firstly, which have incomplete octet. Secondly, which have a tendency to expand their octet, and the thirdly, which are electron deficient. It means they have a tendency to acquire more electrons. Now, we are considering our next category, that which compounds are act as a Lewis base. So, the compounds which can act as a Lewis base are electronegative compound. electronegative compounds or elements will going to act as a Lewis base like F negative, Cl negative, I negative. Now the compounds which are having a lone pair of electrons will going to act as a Lewis base. So second property is compounds having lone pair of electrons like NH3. This is ammonia and this is having a one lone pair of electron on it. Now thirdly, the compounds which can be formed by compounds like C double bond C, C triple bond C will going to act as a Lewis basis. So these compounds will act as a Lewis basis. So in this topic we have discussed which compound will going to act as a Lewis acid and which compound will going to act as a Lewis base. So it is all about the theory of acids and base that the three scientists came and gave their different theories, that is the Arrhenius one, Bronsted-Lowry concept, and the theory that is last one is the Lewis concept of acids and bases. Now we are moving to our next topic, that is salts, and we will discuss a variety of salt in this sequence. And the chapter, this is the last topic of our chapter, that is salt. We will discuss about the normal salts and chemical salt in this chapter. So our next topic will be the salt. So now after the theory of Lewis acids concept of bases, we have our next topic, that is salt, which will be the last topic of our chapter. So our next topic is salts. So salts are basically classified on the two categories depending upon their pH value or depending upon the mode of the formation. So there will be the two categories for defining the salt. The first one will be on the basis of mode of formation, and second category was on basis of pH values. So this will be our two categories to define the salt, that is on the basis of the mode of formation or preparation, and the second category will be on the basis of their pH values. Now on the basis of the mode of the preparation, we have a variety of salt, and on the basis of pH values again we have a three category of the salt. So depending upon the mode of the formation, we have another category. The first category is normal salt. The second category is acidic salt. The third category is basic salt. The fourth category is mixed salt, and the last category will be double salt. So this will be the category on the basis of the formation of the salt. Now depending upon the pH value, we have again more categories. So depending upon the pH value, our categories are acidic salt, basic salt, and the third category one will be neutral one. This will be depending upon the pH value. Now we will deal with the formation, mode of formation. We have our first category, that is normal one, acidic one, basic one, and the mixed salt. And the last category will be the double salt. And in this category, we have acidic salt, basic salt, and the neutral salt. Now we will deal with every type of the salt one by one, but firstly we are describing the salts on the basis of the mode of the preparation. So our first topic will be on the basis of mode of formation. So on the basis of the mode of the formation, we are dealing with our first category, that is the normal salt. So our first category is normal salts. So normal salts are actually those salts which are formed by the complete ionization of the H plus ions in their solution. If there will be the complete ionization of the H plus ion, we can say that these are the normal salts. What are salts? This topic has been discussed in our earlier classes, that when acid react with base, it completely neutralizes these reaction and the salt is formed. So salt will form when acid is going to react with base. So acid plus base reaction will give us the salt, and this reaction is termed as a neutralization reaction that we have discussed earlier. So acid and base will react with each other to give a salt. Now we are on our topic, that is normal salt. So normal salt are formed basically by the complete ionization of the H plus ions. So its definition will be salts formed by complete ionization of H plus ions. It means there will be the complete ionization of the H plus ions in the solution. So we have many examples for normal salt. Suppose I am reacting NaOH with HCl. Now this NaOH is base and this HCl will be acid. Now when the base react with acid, we will get NaCl plus H2O. It means Na will combine with Cl to form NaCl, and the OH molecule will combine with H atoms to form the H2O. So acid and base react with each other to form aqueous salt with the liberation of water. So this is all about the reaction of the normal salt. As you can see there will be the complete ionization of the H plus ions. So H plus ions are completely ionized. So the reaction is termed as a normal salt. We have one more example in this category. So our another example is NaOH plus H2SO4 give Na2SO4 plus H2O. So you can see in this equation, this is a base, sodium hydroxide, H2SO4 is sulfuric acid. Now base and acid will react to form a salt. This is actually the normal salt because again there is a complete ionization of the H plus ions. So this is aqueous salt with the elimination of water. So these are the category of the two salts we have discussed here. This is an example for the normal salt. We have discussed here. So you can see here there is a complete ionization of the H plus ions. So if there is a complete ionization, we can consider it in the category of the normal salt. Now we have many type of normal salt according to their parent salt, and these category I am writing here, but before you can copy it from here. So now we have many type of parent salt and their normal salts. Here I am writing parent salt, and here we have another category, that is their normal salt. So in the parent salt category, firstly we have sulfuric acid. So the general formula for sulfuric acid will be H2SO4. This is actually the parent salt. And how normal salt will be formed from these reactions? In the category of the normal salt, we have Na2SO4, K2SO4, Pb2SO4, etc. It means from this parent salt, normal salt can be formed. Now we have our next example in the category, that is hydrochloric acid. The hydrochloric acid is basically HCl, and from this HCl we can form NaCl, KCl, CaCl2, MgCl2, etc. It means these are the salt of the chloride ion. So this will be our second category. Now we have the third type of parent salt, that is nitric acid. The formula for nitric acid will be HNO3. So from the HNO3 we have again a variety of the salt, that is NaNO3, PbNO3 whole twice, KNO3, etc. So this will be the parent salt and these are the corresponding normal salt. Now we have our last category in this salt, that is carbonic acid. The formula for carbonic acid will be H2CO3. From the H2CO3 we have the variety of salt again, that is potassium carbonate, sodium carbonate, lead carbonate, calcium carbonate. So again these are the variety of salt from parent salt to the normal salt. So we have the 4 categories here. We have many more examples in this category. From the corresponding parent salt we are able to form the normal salt. So this will be the characterization of the parent salt according to their normal salt. So we have dealt with our first category, that is normal salt, and we are left with many more categories that we will discuss in our next session. So this lecture is over for today. Thank you so much and have a nice day.